Okay, students. So let's get started with the MCQs for nuclear physics. The only stable isotope of gold, Au, has 79 protons and 118 neutrons in a nucleus of an atom. How many electrons are there in a neutral atom of this isotope? So, if the atom is neutral, the number of protons and electrons will be same. 79 is your answer. Let's move ahead. The result of the alpha particle scattering experiment give evidence for which of the following? Nuclear fusion, no. Radioactive decay, no. The existence of isotopes, no. The size of the nucleus. Let's further move ahead. The results of a scattering experiment show that a very small nucleus contains most of the matter in an atom. What is scattered in this experiment? Obviously, alpha particles, because this was an alpha particle scattering experiment. Atom P and Q are isotopes of the same element. Okay. How does the composition of an atom of P compare with the composition of an atom of Q? Number of protons in an isotope are same. Number of neutrons in an isotope are different. C is your answer. Let's move ahead. 14,6 carbon represents a nuclide of the element carbon, and 14,7 N represents a nuclide of the element nitrogen. How is a neutral atom? How is a neutral atom of 14,7 nitrogen different to a neutral atom of 14,6 carbon? The nitrogen has one electron fewer. No. The nitrogen has one neutron more than carbon atom. No. Because if you see 14 minus 7, the number of neutrons for nitrogen is 7. 14 minus 6, the number of neutrons for carbon is 8. So this cannot be the answer as well. Nitrogen has one proton fewer than carbon. No. Can you see carbon has 6 protons and nitrogen has 7 protons? No. The nitrogen atom has one proton more. Yeah, D can be your answer because carbon has 6 protons, nitrogen has 7 protons. Let's move ahead. Which particles are found inside the nucleus of an atom? Neutrons and protons. D is your answer. Let's see this. The nucleoid notation of an isotope X is this. How many neutrons are there? How can we calculate the neutrons? We will take the mass number and minus the proton number from this. B is your answer. Let's move ahead. A proton has a charge of Q and a mass of M. What is the charge and what is the mass of an alpha particle? Alpha particle has a charge of 2 plus and has a mass of 4m. C is your answer. Let's further move ahead. One nuclei of a uranium isotope contains 238 nucleons, of which 146 are neutrons. So, how many protons will be there? 238 minus 146, 92 protons. To calculate the number of protons, I took the nucleon number, subtracted it from the neutrons. I got 92 as my answer for protons. So, number of nucleons in the nucleus. Okay. How many number of nucleons will be in the nucleus? What is the nucleus of an other isotope of uranium? Always remember for any kind of isotope, the proton number remains same. Can you calculate the proton number for A? Yes, very easy. 235 minus 143. Let's calculate it. 235 minus 143. This gives you a value of 92. Yeah. If the proton number is same for A and the initial nucleus, then A is an isotope of the initial nucleus. Let's further move ahead. A radioactive nucleus is represented as 23092. Number of which row represents an other isotope of the same element? Okay, we have to give an other isotope of the same element. What are the number of protons? 92. Because in an isotope, the number of protons in the isotope remains same. C is your answer. Let's see this. A narrow beam of alpha particle is fired at a thin piece of gold foil. Okay. What is the final direction of the largest number of alpha particles? The largest number of alpha particles pass undeflected. A is your answer. Let's further move ahead. Which statement about a nucleus of 15,7n is correct? Okay. The nucleus contains 7 neutrons and 8 protons. No. The number of protons is 7 written here. The number of neutrons is 15 minus 7. That is 8. Okay. The nucleus contains 7 neutrons, 15 protons. No. The nucleus contains 7 protons and 8 neutrons. Yes, C is your answer. This is also verified by our calculation. Okay. Let's further move ahead. The diagram represents the nuclei of 3 atoms. Okay. The shaded region represents protons, which are the isotopes of the same element. Which are the isotopes of the same element. What have I told you? Isotopes have the same proton number. Can you see P has 2 protons and R also has 2 protons? So P and R are isotopes of each other. B is your answer. Let's move ahead. In the Geiger-Marsden experiment, a beam of alpha particles is fired at a thin sheet of gold foil in a vacuum. What is deduced from this experiment? Alpha particles are repelled by electrons? No. Atoms contain air? No. Electrons are found in the atomic nuclei? No. Nuclei are much smaller than atoms. D is your answer. Which particle has the smallest mass? Always remember electrons have the smallest mass. B is your answer. A neutral atom of chlorine 37 is compared to a neutral atom of argon 37. Okay. How do the number of electrons and the number of neutrons in each of these atoms compare? Can you see chlorine and argon are both different elements. Hence, they will have different proton numbers. And if your atoms are neutral, and if you have different proton numbers, that means you have different electron numbers. Because in a neutral atom, the number of protons is equal to the number of electrons. C and D will get cancelled out. Also, your number of neutrons will be different as well. A is your answer. Let's move ahead. The composition of 4 nuclei are shown in the table. Which 2 nuclei are isotopes of the same element? Which trick have I told you? Look for the same number of protons, 88 and 88. P and Q are isotopes. A is your answer. Which radioactive isotope can be used for measuring cracks or flaws in metal components? An alpha particle emitter with a half life? No, not an alpha particle, because alpha particle cannot travel a greater distance in air. A gamma emitter with a half life of 5 years. Yes, that's correct. That's pretty correct. Okay. 3 types of radiations emitted by unstable nuclei are helium nuclei, short wavelength electromagnetic waves, and electron. What are these 3 types of radiation? Helium nuclei is what? Helium nuclei is an alpha particle. Electromagnetic wave is a gamma particle. Electron is a beta particle. A is your answer. A sample of radioactive isotope produces a count rate of 1000 counts per minute. The half life of the isotope is 1 day. What was the count rate of the sample 2 days ago? Okay, so you have to move forward. Let's say you are 10,000 today. What would have been your count rate yesterday? Yes, what would have been your count rate yesterday? 20,000. What would have been your count rate day after yesterday? 40,000. Keep doubling it. D is your answer. This is day 1 and this is the second day. Let's further move ahead. A radioactive material decays by this process. What is material X? What is this material? Can you see we are adding 1 to the proton number? Whenever we used to add 1 to the proton number, which type of particles used to be emitted? An electron. Let's further move ahead. A nucleus of polonium 21584 decays by emitting an alpha particle, and the resulting nuclei then decays by emitting a beta particle. Okay. So first of all, you are emitting an alpha particle. If polonium 21584 PO emits an alpha particle, this will become what? 211 PO 82. Now, if this decay is a beta particle, what will happen? 211 PO 83, because proton number gets added by 1. So 83 and 211, B is your answer. Let's further move ahead. Which rho gives the range and electrical charge of an alpha particle? The charge of an alpha particle is positive and it can travel only a few centimeters. B is your answer. Which rho states the nature and the range of beta particles in air? Beta particles most closely resemble an electron. A and B get cancelled out. And they can travel from 10 to 100 centimeter within air. Let's further move ahead. 3 types of, I guess we have done this before. In the Geiger-Marsden experiment, a beam of alpha particles fired at a thin sheet of gold in a vacuum. The majority of the alpha particles pass straight through the sheet without being deflected. What does this show? The alpha particle is uncharged? No. The alpha particle is very large? No. The nucleus is very small, was the conclusion that we derived. Alpha particles can pass through an electric field or a magnetic field. How is the path of particles affected by these fields? Alpha particles is positively charged, so it will be deflected towards the negative terminal of the electric field. And alpha particle flows in the same direction as the current, so it will also be deflected by the magnetic field. A is your answer. Let's move ahead. A nucleus of an isotope of cobalt is represented by this. What is the composition of the nucleus? You have 27 protons, obviously. C and D get cancelled out. How will you calculate the number of neutrons? 59 minus 27, that is equals to 32. A is your answer. Let's further move ahead. The diagram shows how the thickness of paper is measured during manufacture. If the sheet is too thick, fewer beta particles can reach the detector. Okay. Why are beta particles used? Because alpha particles are all stopped by the paper. Yes, this can be my option. Alpha particles make the paper radioactive. No. Gamma particles are all stopped by paper. No. Gamma particle. No. A is the correct answer. Because alpha particles are all completely stopped by the paper. So you need some source that passes through the sheet of paper. Let's see this. Which statement about all three types of radioactive emission is correct? They can all be absorbed by a thin aluminum sheet. No. Gamma rays passes through aluminum sheet. They are all deflected by electric fields. No. They are all deflected by magnetic fields. No. They all cause ionization of gases. Yes, D is correct. D is correct. All cause ionization of gases. Let's further move ahead. Different radioactive emissions have different characteristics. A student lists the following characteristics of an alpha particle. It has a positive charge, yes. It has a high penetrating ability, no. It is a component of electromagnetic spectrum, no. A is your answer. Let's further move ahead. In one radioactive decay, radium 226 decays to radon 222 as shown. Okay. So basically, what is happening? Your mass number is decreasing by 4, your proton number is decreasing by 2. This leads to an emission of alpha particle. Only B is your answer. Let's see this. An isotope of lead is radioactive. After 3 decays, 2 betas and an alpha have been emitted. Another radioactive isotope of lead is formed. What is the mass number or nucleon number of the new isotope? Okay, so basically you have this initial isotope, and first of all you are having 2 beta decays. Okay, so if a beta decays, your proton number increases by you can say 183 pb. Again a beta decay, 212 84 pb, and then an alpha particle will get decayed. If an alpha particle decays, what happens? Your mass number decreases by 4, your proton number decreases by 2. So your nucleon number at the end of all the emission will be 208. B is your answer. Let's see this. What does the alpha radiation give off by radioactive? What does the alpha radiation given off by radioactive nuclei consist of? Fast moving protons? No. Helium nuclei? Yes. Let's see this. The aluminum foil is used in cooking. Okay. The diagrams show a system used to control the thickness of aluminum foil being made in a factory. What is the most suitable radioactive source for the system? Obviously, beta particles. Half life of the beta particle should be greater, let's say 6 years, so they do not diminish during the process. Okay, a beam of alpha particles, beta particles, and gamma rays passes into a magnetic field. Okay, which diagram shows their path in the magnetic field? Okay, so the first thing that you must notice is gamma is deflecting in A. That wouldn't be your option because gamma remains undeflected. Gamma rays remain undeflected. Alpha and beta deflect. And if you see here in option D, your alpha is remaining undeflected. That is also not an option. Can you see B? Yeah. In B, your gamma is remaining undeflected. Alpha is deflecting towards the top side, beta towards the downside. B is your answer. Also, another way to spot this is always remember beta deflects more. Always remember beta deflects more than any one of these three particles. Gamma remains undeflected, alpha deflects by a lesser amount. A nucleus of phosphorus this emits a beta particle to form a new nucleus. Okay. Emits a beta particle. Okay. What is the nucleon number and what is the proton number? So let's say this is your initial phosphorus. If you emit a beta particle, it will become 32, 16 phosphorus. Your proton number increases by 1. So, do you find any proton number with 16? Yes, D is your answer. Let's further move ahead. Which states the three types of radiation emitted by radioactive isotopes in order of their ionizing effect highest to lowest? Always remember alpha particles have the highest ionization effect, then beta and then gamma. A is your correct answer. Let's further move ahead. A uranium nucleus of 23892 decays to thorium by emitting an alpha particle. What is the resulting nucleus? Okay. So if you are emitting an alpha particle, your mass number decreases by 4, proton number decreases by 2. So 234 and 90 should be your answer. 234 and 90. Yeah, A is my answer. Let's move on to the next. When a radioactive atom decays by alpha emission, its nucleus loses one proton only? No. One proton and one electron? No. Two protons and two electrons? No. Two protons and two neutrons. D is your answer. This marks the end of past papers for nuclear physics. If you have any questions, you can ask.